All right, so continuing on with our 6.2a lesson, we're going to talk about the second quadrilateral, rectangles. Okay, so first let's talk about the key defining features of a rectangle. A rectangle must meet these 7 categories. Remember, parallelogram only had 5. Rectangle's a little bit more exclusive. You have to have 7 criteria to be classified as it. Now, one thing you may notice that if we flip back and forth between these, okay, on parallelogram, number 1, opposite sides are parallel. On rectangle, opposite sides are parallel. Number 2, opposite sides are congruent. Opposite sides congruent. Number 3, opposite angles congruent. Opposite angles congruent. Number 4, consecutive angles supplementary. Consecutive angles supplementary. Number 5, diagonals bisect each other. Diagonals bisect each other. So, because of that, we can basically say that every single rectangle is a parallelogram. Okay, this is kind of the whole argument of all chihuahuas are dogs, but not all dogs are chihuahuas. Well, all rectangles are parallelograms, but not all parallelograms are rectangles. Okay, so with a rectangle, it has to meet all 5 of the same features that a parallelogram has to meet, plus 2 more. So 2 more things is that in a rectangle, there must be 4 right angles. Okay, so in this picture, again, I'm talking about the whole picture. Okay, so ignoring the diagonals for a second, that means that the entire picture must be a right angle. Okay, so even up here, even though I've got it split into 2 uneven pieces right now, I know that these 2 must add up to equal a right angle. Okay, so 4 right angles. And then lastly is number 7, the diagonals must be congruent. Okay, so number 5, not only do the diagonals have to bisect each other, meaning they have to cut each other in half, but they also have to be congruent to one another. So if we were to combine numbers 5 and 7 together, what that basically means for us is that if this diagonal is cutting this one in half, but if these 2 diagonals, the whole thing, are also equal to one another, then what that means by combining 5 and 7 together is that these diagonals, when they cut each other in half, it creates 4 equal half diagonals. Okay, so that's why for each of these half diagonals, I put 3 tick marks. Because if I combine 5 and 7 together, then that means that I've got 4 congruent half diagonals, or 2 congruent whole diagonals. So that's the key defining features of a rectangle. Now let's dive a little bit deeper. Okay, so example 1. Quadrilateral RSTU is a rectangle with diagonals that intersect at P. Okay, so first up, let's just make sure we get our figure drawn correctly. Remember, as we are labeling this figure, we have to label the vertices in consecutive order. Okay, so I've put R up here in the top left. So that means I've got 2 options now. I can either go clockwise or counterclockwise. So I decided to go clockwise. R, S, T, U. Okay, so, and they intersect at point P. So I drew one diagonal with a solid line and another diagonal with a dotted line, and they intersected that point right there, point P. So if the measure of angle RSU is 3x minus 5 degrees, and the measure of angle UST is equal to 4x plus 4 degrees, find the value of x. Okay, so in my figure, go ahead and label those angles. So angle RSU, that's going to be this piece of this top right angle, and angle UST, that's going to be the other piece of the top right angle. So I'm not given any other angle measures in this figure, but I need to go back to my key defining features. So we had the same 5 as parallelogram, and then we had 2 additional ones. 4 right angles and diagonals are congruent. Well, if we look, 3x minus 5 and 4x plus 4, they are both 2 pieces of the same angle, the same corner angle. So since in a rectangle, all of the big corner angles are going to be 90 degrees, then that means when I take these 2 values and I add them together, they'll also equal 90 degrees. Okay? So 3x minus 5 plus 4x plus 4 will equal 90. Combine my like terms, I'll get 7x minus 1 is equal to 90. Add 1, I'll get 7x is equal to 91. And then divide by 7, and I will get that x is equal to 13. Okay, so you may notice in some of my answers that I'm saying like 13 degrees or just 13. That's just depending on what the question is asking for. So if in the question one of these angles was just x, then I would leave my answer as x is equal to 13 degrees. But in this particular example, since x was not an angle by itself, That's why I just let my answer just x equals 13. So you may have noticed that that's just a little nitpicky notation thing that I'm doing. Um, Saying x equals 13 degrees would not be wrong. Okay. Example 2. Quadrilateral ABCD is a rectangle with diagonals that intersect at point P. Okay, we're given that AC has a length of 4x minus 13 and DP has a length of x plus 7. So we need to find the value of x. Okay, so in my picture, quadrilateral ABCD is a rectangle with diagonals that intersect at point P. So AC, that's a whole diagonal. Okay, so AC is this whole thing, has a length of 4x minus 13. DP, that's a half of a diagonal, has a length of x plus 7. And we need to find the value of x. Okay, so for this particular problem, there's two ways that we could tackle it. We could either tackle it as I'm going to leave AC alone, or I'm going to leave DP alone. Okay, and I'll work it out both ways just so you see that we are going to get the same answer whichever path we decide to take. Okay, so with this first one, what I decided to say is I decided to say 2 times x plus 7, okay? Because here's the thing. AC is this 4x minus 13, okay? So that's that. X plus 7 is this dp, okay? So we know that. So back up here in our defining features, we talked about how diagonals bisect each other and diagonals are congruent. When we combine those two together, that means that all of the half diagonals are congruent to one another. Well, if the half diagonals are congruent to one another, then that means what if I take two half diagonals and add them together? Well, two half diagonals are the same as one whole diagonal. So down here, this is a whole diagonal, this is a half diagonal. So if I want to set up an equation where these two are equal, I have to take 2 times the half diagonal to equal the whole diagonal. So I've got 2 times x plus 7 is equal to 4x minus 13. Okay? Because if I'm going to set these two equal to each other, I can't say x plus 7 is equal to 4x minus 13 because x plus 7 is just a half diagonal. I have to say a whole diagonal plus another whole diagonal. Or alternatively, what I could do instead is let's say I want to leave dp alone. Well, if I leave dp alone, then I need to do something at AC. Well, if DP is a half diagonal, I need to do something to AC to make it a half diagonal. So if AC is a whole diagonal, I'm just going to take 1/2 of AC. So another way we could set this up is x plus 7 is equal to 1/2 4x minus 13. So I'm going to work this one out side by side with this one. So you already see my work and my answer with this. I got 13.5. So let's work this one out and see if I get the same thing. So distribute that 1/2. I'm going to get x plus 7 is equal to 2x minus 13 over 2, or 6.5 if you'd rather have that as your answer. Okay, so now from here, I'm going to add 13 over 2, which is also 6.5 to this side, and I'll get 13.5, or excuse me, 13 over 2 is 6.5. So I add 6.5 to both sides. I get 13.5. Subtract x. And so there you have it. Either way, I'll get 13.5 for my answer. Okay, so whether you decide to leave the whole diagonal alone or the half diagonal alone, you'll get the same answer either way. Okay, next up, example 3. Quadrilateral JKLM is a rectangle with diagonals that intersect at point P. LP is equal to 3x plus 7, and MK is equal to 26. Find the value of x. Okay, so example 3 is similar to example 2. There's going to be two different ways we can go about solving it if we want to. Okay, so getting our figure set up right. So we have JKLM with diagonals. I put one as a solid line, one as a dotted line just to distinguish the two. They intersect at point P. So LP, which is a half diagonal, has a length of 3x plus 7. And then MK, which is a whole diagonal, has a length of 26. So I need to find the value of x. Well, if I know that LP is a half diagonal, then that means that I need 2 LPs to equal my whole diagonal, which is MK. So 2 times 3x plus 7 is equal to 26. And again, if you rather would want to set it up as LP is equal to 1/2 MK, that would also work as well. Either way you would prefer to work it. So if I'd prefer to work it this way, I could say 3x plus 7 is equal to 1/2 of 26, which then 3x plus 7, multiply these together, will give me 13. Subtract 7, I would get 3x is equal to 6, divide by 3, and I would get x is equal to 2, whichever way I prefer to work it. So if I prefer to change the half diagonal or change the whole diagonal, let me make that a equal sign. Either way would work perfectly.